I also be here today to talk to you all, you landlubbers, about Firebase. And Firebase, as most of you know by now, be an old pirate negotiation tactic. When the other party is not amenable to your demands, you set their base on fire. After that, you find that they tend to be much more agreeable. I suggest you try it out during your next meeting with your manager or a client. Either way, we pirates like to call it a win-win, or a win and screaming on fire. Either way, the point being, you win, and that's good. But, as Jenny may have mentioned earlier, Firebase also be a fine collection of products for developing your app. And this be included everything from authentication for easy sign-in, to the real-time database, to hosting for easy hosting of your web files on a global CDN, to analytics on your mobile devices, to a cross-platform notification service. It be a whole lot more. But there be two products I want to be talking to you about today. The first, which I'll mention briefly, is Firebase Test Lab for Android. Now, I know a lot of people think of automated testing as a way just to check for crashes and things setting on fire. But Firebase Test Lab can also test for performance. So if you use Firebase Test Lab, you can run scripts. Either they can be your own or some robo-tests on real devices that we have in actual data centers around the world. And you'll be able to see CPU usage and memory and frames per second and all of that alongside a nice video of your app. So when you see a CPU spike going on in your app, you can jump to exactly that point in the video and see what was happening in your app at the time when your performance went all belly up. So it's great for learning about your app before you launch. But most of our talk today will be talking about what happens in your app performance after you launch. And that's where Firebase Performance Monitoring comes in. Because I think we all know no amount of testing that we do, either automated, in a data center, or in our office with our fancy Wi-Fi, is going to match the results of some real users out there in the world. So what really happens when a user in some far-off part of the Portuguese Empire uses your app while on horseback using some device you never heard of? That's something you just can't simulate in a data center. And it's why we need a tool like Firebase Performance Monitoring to measure how your app performs in the real world. So like all Firebase products, you can start by installing a CocoaPod on iOS or adding a line to your Gradle file on Android. And just by installing the SDK, you get a bunch of very nice dashboards and some information automatically within the Firebase console. But there'll also be specific areas of your app that you're probably going to want to measure. And so for that, we give you the APIs to do that as well. And maybe we can talk about some of these. But first, perhaps this might be a good time for a little apology. I know I'd be at the HTML5 conference, and I'd be here today to talk to you all about a product that really only works on native mobile apps. None of this fancy open web stuff. And for that, I do apologize. But part of the reason is that this be a much tougher problem on mobile. Sure, it's not always easy on the web, as many of you know, but you have things like page loads, and these page loads that usually correspond to something you know your user's trying to do at the time. And then you can kind of figure out what part of your app might need work. But on mobile, it'd be much more of a black box or locked treasure chest. It'd be like a locked treasure chest. You can't see what's inside. And very often, you just have no idea what's going on your user's mobile device. So when they complain, you just don't know where to start looking. But also, now that I think about it, this be a pirate talk. And pirates don't apologize or have respect for other platforms. So you know what, my HTML5 web lovelies, I'm not apologizing. You're going to listen to this talk full of app review processes and closed ecosystems. And would you like your choice of web browser? Well, you can't have it. You're going to like it. Or you're going to be on pager duty for the next 3 weeks, and nobody wants that. It's a pirate talk. We're pirates. That'd be more like it. So back to Firebase Performance Monitoring. So we need to introduce you to a couple of different concepts. See, there are two main categories where your apps can be slow. The first being your app's code performance. What kind of delays your users are seeing, if they're seeing frame drops in your animations, things like that. And to measure those sorts of things, we've added something that we like to call traces. A trace simply records data between 2 points within your app. And this can be anything that you want to measure within your app. Often it's waiting for a block of code to complete, but honestly, it's anything that might have a beginning and an end. And it turns out that be most things, except the universe and the sea, which be endless. So perhaps you want to measure the time between when your users click on an item and they see the full product screen within your app. Or it could be as fine-grained as waiting for a database fetch to complete. Or it could be as long as a full checkout flow. And it turns out at this point, this really be less about code performance and more about the performance of your user experience, your UX flow. But it turns out that be important too. And this can be a perfectly valid thing to be measuring in Firebase Performance Monitoring. We're pirates. We don't have a lot of rules. Measure whatever you want. It's got a beginning and an end. You can add a trace to it. So the code to add a trace, it'd be pretty straightforward. You create a trace object, and you give it a name, and then you can stop it later. And the trace is then something that you will see within the Firebase console. And in terms of metrics, you get the trace duration out of the box, and that be how much time it took between the start and the stop. And so essentially, you can use a trace like a timer, but it actually can contain more information than that. Because you can attach custom metrics using a counter API, which we see here. So you can, if you want to keep track of anything that might be happening during a trace, whether it be a dropped frame or a disk call or a cache hit or a network request, you can do that simply by giving your counter a name, attaching it to your trace, and then you'll be able to see all these custom metrics, when you're looking at your trace within the Firebase console, and I'll be showing that to you in a little bit. You do get a number of traces out of the box. Probably the most important here be app start, which measures the time between when your code is initialized and when your app is responsive to the user. But you can certainly want to think about places where you might want to start creating your own custom traces too, and we can talk a little more about that a little later. So those are traces. Now the other main area where your app can be slow, network calls. Yes, those things. Now monitoring network calls is very simple. You don't need to write any code to do it. Performance monitoring will simply observe every request that you make, calculate the duration when they're sent from their app to when you get some kind of response. And when you do that, you get a number of different metrics, including response time, requests and payload size, and success rate. And for the purpose of determining success, any request that goes out and comes back with an HTTP code that's not in the 400 or 500 range is considered a success. And so for all these metrics, network calls or traces, you have the ability to slice and dice these, not like in a piratey way with cutlasses and such, but like in a data analytics way, which is less piratey but more useful. And you can break out any of these reports by app version or device or country and so on. And this can help you find out if there are any contributing factors that can help you then narrow down what's going on within your app when something seems to be slow. And so perhaps the best way to explain this all would be to spin you a tale of treachery and redemption. So we're going to tell our little tale about Jane. Jane is a fine bonny lassie who, despite not having a mouth, apparently, I don't know how she drinks that coffee. It's a mystery. She'd be the main captain and developer of an e-commerce app, Peglegger. It'd be like Uber, but for peg legs. So she spent the last 6 months building her team's iOS and Android apps, and how she's finally getting ready to launch. And it just so happens she'd be using Firebase for many things, like analytics. And she decides right before she launches, you know what? I'm going to add in the Firebase Performance Monitoring as well. So we don't have any custom code, no time for that, but we can at least add the library and see what we get with the default behavior. So let's see what happens in fortnight number 1. Jane decides to release version 1.0 of her app over in the British colonies over in the New World. They all seem like friendly types. So let's see how it goes. Oh dear. Well, we're getting some 2-star reviews, and people are saying it's taking too long to start. So what do we do? Well, yes, that certainly seems like the piratey thing to do. We just talked about that earlier. But it turns out this be against App Store policy. So we have to look for other solutions. So let's head over to the Firebase console instead. And with that, let's turn off mirroring and switch over. All right. Zoom in. Can you all see this? R, R. Let's hear an R if you can see this. R. Excellent. Okay, and so I'm going to get out my cheat sheet because I got to make sure I'm doing this all right. So here we are in the Firebase Performance Monitoring section. We're looking right now at the dashboard, and we have a whole bunch of high-level data for our traces and our network calls, all aggregated for our app. And this is all the out-of-the-box stuff. So on our first card, we have our most frequent traces, and right now we just have the 3 automatic ones I talked about earlier. App in the foreground, app start, app in background. Now, our app start median duration, this not be looking too great. We want this to be a little shorter, so we'll be getting back to this one. But let's take a look at some of our other cards. So we have our network success rate. We see how many of our network calls were successful. We can hover over some of these and see particular, success rates for any particular date. Down here, we have network latency by country, and I can see that the US is at 1 second, and US, what's that? I thought it was I don't know what that stands for. Apparently, the British colonies is abbreviated US. And Canada, they both be looking good, though. That's the thing to get out of this. Over here, we can see our network responses by MIME type. And not too surprisingly, the majority of our network volume be images, because people like their pretty pictures of peg legs when they're shopping. And then down here, we have app start time, version over version, and, well, this be interesting. Version 1.0, the version we just put out, has a much higher app start time than our previous ones. By the way, in these graphs, this dot here be the median, and this line here represent the 5th to 95th percentile. So this all be good information, and it does seem like something is wrong with version 1.0, but maybe we should find out if there are any other complicating factors here. So I'm going to click on View App Start Duration, and we can take a look. And this gives us a further breakdown of this app start trace. So we can see, once again, yes, something is happening with version 1.0, but we can see broken down by device as well. Now, the iPhone 6 be slower, but this is not surprising since it's an older device. So this actually is raising no red flags, or, well, yeah, they had red flags. Yeah, this be raising no red flags. Country also looked good. OS version, yes, older OS versions be slower. Again, that's to be expected. So, yes, we can be pretty sure that whatever is going on happens to be with version 1.0 of our app. And so with that, let's go back to the slides. So we jump back into our code, and sure enough, yes, we have this blocking call in our app did finish launching method, and there's no reason this need to be blocking, so we can make it asynchronous. And, oh, that's much better. Huh. So version 1.1 goes out with a fix, and that be the end of fortnight number 1. So let's see what happens on the second fortnight. And this will be an interesting one, because it turns out the spice trade is going strong, and pirates in other parts of the world discover that they need peg legs too. So we think maybe this would be a good time to expand our operations to India. So Jane jumps back into our console to see how things are going. All right, so here we are in week number 2. And the first thing we're going to do is look at app start. And sure enough, it looks like when we released version 1.1, our app start time went back down to something much more reasonable. So that'd be good tidings. The bad tidings, well, it looks like now that we have data from India, it would appear as though our network calls are quite slow. If we hover over, we can see our average latency is 7.2 seconds, which is much, much higher than what we would like. So how do we investigate this? Well, let's be clicking on the Network Requests tab to see what be going on here. So here we have a bunch of URL patterns. This be all the network calls that our app be making. And up here we have, I'll expand this so you can, that might be all we get. You get your analytics. And here we have our product images. Here we have seeing our product details, adding items to the cart, and so on. And when you see an asterisk like this, it means there'd be a dynamic path segment within our URL. Clearly, in most of these cases, it'd be the actual product ID. And Firebase Performance Monitoring be smart enough to coalesce all of these into one URL so that you know that this is probably due to, yes, all the same kind of call, and you don't have to go through all these individual URLs. So for each of these, we can see our average response time, our success rate, and a number of requests. And sure enough, if you look closely here, we see some warning icons as well. One of them, this be complaining about latency, and it's saying, oh, your response time, it's taking much longer than it should be. We want this something more like 2 seconds. And this one here is telling us that our success rate for our checkout calls, that is under 90%, and that be cause for concern. We never want our app to break when people are trying to buy something. So this is definitely cause for concern. So let's click on this to find out what's going on. And here we get a bunch of metrics. We got the response time, we've got our payload sizes, and we've got our success rate. And so I'm going to click on View More here to get to further breakdown. And so you'll see at the top here, we have a breakdown of all the requests. Here are successful ones, and here are all of our errors. And it looks like 400 errors take up a very, very small portion of our errors. Most of them seem to be in the 500 range. More specifically, they're actually 500. So that gives us a pretty good clue of where errors might be. Something might be wrong with our server. But let's take a look at some of the breakdowns of these calls to see if there's anything else that might be going on. And most of these be looking okay. App version seems to be okay. It's not changing too much by app version. Device, country. Oh, country. Well, this 0 success rate. This might be a problem. I'm pretty sure this is a problem. So we're going to have to fix that. But at least now we have a pretty good idea of where we need to go to fix these. And just to confirm, we can go up and click on our Overtime tab, and we can see that, sure enough, our 500 errors spiked up right around the time we released our app in India. So we think we know where to look here. And yes. So let's go back to our Network tab and look at that other warning about our response times. Well, this probably also has to do with our app launch in India, and we could confirm this just by filtering up here. So I'm going to click on this filter, and here are a bunch of metrics that we automatically collect about your app. And I'm going to filter all of these reports by country, and then let's look at India. And, whoa, boy. Whoa, Nelly. That's not good. Whoa, Nelly is not a pirate term. That's how bad it is. It's making me say non-pirate terms. So this is just terrible. And sure enough, yes, there's our 0 success rate. So we think we probably have a good idea of what we need to fix. Let's look at fixing them. So the first thing we need to do is keelhaul this 500 error. And we're going to do that by looking at our server code. And, whoops, I forgot to switch to this. There we go. Better. All right. So sure enough, it looks like we mislabeled one of our locales for India. Hindi was misspelled, and we were not coding defensively, and so that surely accounts for some of the errors on our end. Luckily, this turns out to be an easy fix. But what about the slow response time? Well, it turns out Jane had a service running for all of her images that ran out of a hosting site in Boston. And while this worked great for her users in the colonies, this was a bit of a problem for our users in India. Luckily, there are services around that can help with this, including our very own Firebase hosting, where all your files can be served over a global CDN. So if Jane switches to that, her files are now cached at CDN edges all over the world, and now our users in India can get to their content much faster. And so we released these fixes all bundled up in version 1.2, and that be the end of Fortnite 2. So let's move on to Fortnite 3. So things are starting to look a little better. Our reviews are a little more positive. People aren't abandoning our app because the pictures aren't loading. Server errors are gone away. So are our users happy? Of course not. They're our users. They're never happy. Why do we keep making apps for them when we could be like just storming their villages and stealing their stuff? It's beyond me. We should investigate our business model. But perhaps this specific user does have a point. In many parts of the world, data still be very expensive. And if these beautiful bytes that our app is downloading is killing their data plan, they might stop using our app, and that would be bad. So Jane decides, let's go back to the console to see what we can do. And so let's jump over here to our next week. So if we go down here, we can see our breakdown of network volume by MIME type. And as we sort of mentioned before, our app is downloading lots and lots of lovely images of peg legs. And Jane realizes that very clearly this could be an area where we could be caching these images. Like, we don't need to go out to the network every time. It turns out peg leg styles don't be changing that much, only really once a year during the peg leg summer show in Milan. And so we think, well, gosh, we can fix that. Let's go back to the code and see if we can. Oh, hey, don't you get away from me. You naughty little slides. There we go. All right. Ha-ha. So one of the first things Jane does to start her image cache is define a cache size. Now, defining something like this is okay, but hard coding your cache size like this could be a bit of a problem. Because what happens when she ships her app and realizes she has this defined wrong, right? Maybe it really should be 25 megabytes. Maybe it should only be 10 megabytes, and it turns out we're taking up too much space on our users' devices. Well, that would take an entire app release cycle to fix and to tweak. So instead, we're going to be looking at Firebase Remote Config. If you've never used a remote config before, it'd be like a key value store that lives in the cloud. Your app can download new values when it starts up, and then you can change your behavior on the fly based on these values that you download without needing a new app release. So let's switch over to the console again. And I'll zoom in so y'all can see it in the back. And so now we're in the remote config section of the Firebase console. And what we're going to do is add our first parameter, and we're going to give it a name, something snazzy like cache size. And we're going to start by giving it a default value of 0, because we want to roll this thing out gradually and see how it goes. So this add value to condition feature, by the way, this would let me roll out different values to different people. And I could break this up a number of different ways. For instance, I could set this to a larger number to a very small random percentage of people. And that might be a nice way of sort of gradually rolling out my feature around the world. Try it first with the small test group. Or I could change it up by country if I realize that folks in India want different cache sizes than folks in the colonies. But for now, just to keep things simple, and because it wasn't baked into the demo, I'm just going to say add parameter. So we've been publishing our changes. And let's go back to the code again. Oh, why do we keep going back to the code again? Okay, there we go. And it all worked this time. Okay, So, so now instead, Jane sets up her code to go through remote config to determine her cache size instead of using a hard-coded value. And then we can add the logic to perform the caching. Turns out this not be actual code. Adding image caching is slightly more complicated than this. But if only it were that easy. But let's assume that she's added it. Well, how does she know that the code she added actually worked? Well, for that, we need to monitor it. If only there were some type of monitoring service. Oh, right. That's the point of the talk. So we can use performance monitoring and use a custom trace. Remember, these are the measurements that record some duration in our app. And so we can create a new trace called image fetch and start the trace when we begin to fetch our image. And then we can stop the trace when the fetch is complete. But now within the caching logic itself, we can also create two counters. The first can be a cache hit counter, which will get incremented anytime we find an image in the cache. And then the second can be our cache miss counter. And this basically takes care of our monitoring. And so now Jane can ship version 1.3 of our app. And so let's see what happens in fortnight number 4. And I'll be zooming in. There we go. So let's see what's going on here. Well, good news, it looks like India is no longer slow. It would appear as though our CDN appears to be working, and that's good. But what about our image cache? Well, let's click on traces. And here we can see, once again, we have the automatic traces that always come with the service. But then this be our image fetch cache, or trace that we recently added. So let's click on that. And here we get the duration, as well as our custom counters. And right now, our cache hits appears to be 0, because as you remember, we defined our cache size as 0 within remote config. Well, now Jane decides she'd be ready to actually turn on the cache. Let's see what happens. So we can go into remote config and change our value. So it goes from 0 to 20 megabytes. We can save this, publish our changes, and then over the course of a couple hours, this value will get propagated to devices all over the world. And then we can go back into performance monitoring, and we can reload our page. And now it looks like we're starting to get some cache hits. And this is nice. And if we switch over to overtime, sure enough, we can see that our cache hits are going up and our cache misses are going down. And by going back and forth between remote config and performance monitoring, we can continue to tweak our cache values until we actually find something that seems to work well for the majority of our users. So people finally start noticing that our app is performing better. They start writing better reviews, and Jane is finally happy. Oh, look, and her mouth is back. That's fantastic. And so I think one of the key advantages to having something like this, something like performance monitoring, is that it helps make you more aware of your blind spots, which as pirates, we tend to have a lot of because of the whole eye patch thing and everything. It also makes you aware of the kinds of issues that you might have in your app that you wouldn't necessarily know about until your users start complaining about them and writing nasty reviews, and maybe we want to catch it before that happens. And this be something that we see with our partners all the time. Here we have a bunch of happy quotes from a bunch of happy partners that I assure you are genuine and absolutely not because we took them hostage and refused to let them go until they gave us a soundbite. So one developer in China used network monitoring to optimize the loading of a banner, which was going slower than they realized. Another developer discovered opening their chat window, which you would think would be instantaneous, took longer than they expected. Another developer, a video app in Turkey, actually started creating customized solutions per device and OS level, all based on data that they were getting back from performance monitoring, which again is pretty nice and would have been a giant pain in the tuchus to actually do if you didn't have this involved. Tuchus is a pirate term. I looked it up. So if you want to find out more, you can go to firebase.google.com and click on performance monitoring. And with that, I'm going to say thank you very much for coming. And in retrospect, I should have been much more drunk before giving this presentation. So I think I'm going to go and remedy that right about now. Peter's going to go up here and say a few last words. Thank you.